This video will help you solve for large linear system using iteration methods. The iteration method that I'm gonna use is the Jacobi method. If you guys are wondering where does the word Jacobi came from, simply it is named after Carl Gustav Jacob Jacobi. He's the one who invented the Jacobi method. So we begin with an example. 4x minus y minus z equals 3, negative 2x plus 6y plus z equals 9, negative x plus y plus 7z equals negative 6, and their initial points are 0, 0, 0. As we can see, on the first equation, x has the greatest number, which is 4. On the second one, y has the greatest number, which is 6. And then the last one, z has the greatest number, which is 7. Always remember that using this method, we should always keep the pattern for a better and a more satisfying result. If you don't want to have a hard time in determining which letter should have the greatest number, simply draw a diagonal line. Here's our diagonal line to have a guide to identify which should have the greatest number. Then the next thing we're gonna do is isolate every letter that has the greatest number. Here on our first equation, x has the greatest number, right? So that's 4. We're gonna isolate x. Simply, here's the result. In this part, we isolated the the letter that has the greatest number. So x equals to 3 plus y plus z all over 4. Y equals to 9 plus 2x minus z all over 6. Z equals to negative 6 plus x minus y all over 7. After isolating the three equations, there, substitute the initial points. Here, there you go. Keep in mind that the first number here indicates the first letter, which is x, and so on. Then there you go. Gonna substitute 0 on every letter. As we can see, they are already computed, but let's try to compute it again. 3 plus 0 plus 0 all over 4. I did it. There you go, 0.75. 9 plus 2 times 0 plus 0 all over 6. It's 1.5. There you go. And lastly, negative 6 plus 0 minus 0 all over 7. Negative 0.8571. So there you have it. These are the new values. 0.75 is the new value of x, 1.5 is the new value of y, and negative 0.8571 is the new value of z. The next thing we're gonna do is substitute these values again on the indicated system, which is this system. Okay, so there you go. There you have it. The new values are already substituted here. I also already computed them, but let's try to compute them again. So 3 plus 1.5 minus 0.8571, answer over 4. There you go, 0.9107. 9 plus 2 times 0.75 plus 0.8571 all over 6, 1.8928. Negative 6 plus 0.75 minus 1.5 all over 7. There you go. Negative 0.9643. Again, we're gonna substitute this three numbers, three new values, on the system again to have a less percentage of error. To know if how many percentage of error you got is use this formula: current minus the number before the current over the current times 100. And then the next thing you're gonna do is add the percentage of error of each letter, and then divide it on the number of letters. So here in our example we have 3 letters, so percentage of x, percentage of y, plus percentage of z all over how many letters? 3 letters, which is so 3. Then you'll get the how many percent of error you still have. So there you have it. I hope this video helped you